that of 1,000 people who said that they attended religious services at least once a week, 31 stopped to help a person with car trouble. Of 1,200 people interviewed who had not attended a religious service at least once a month, 22 stopped to help a person with car trouble. At the 0.05 significance level, test the claim that the two proportions are equal. So over here, the claim is what? Equal means P1 is equal to P2. Okay, this one includes equality over here, therefore it goes where? It's going to go on the top. What's the H1 going to be? The not equal symbol. So this is a two-tail test. So we have N1 is 1,000. X1, that's the number of successes in our first group, is 31. And then N2 is 1,200 people, and X2 is 22. Just remember, proportions can be given either as a number of successes or it could be given as a percentage, in which case we would have to convert it. Question? Yes. Right there. Yeah, help yourself. All right, so we are comparing two proportions. Remember, sometimes that's given as an X value, sometimes it's given as a percentage. If it's a percentage, we would have to first convert it. But when it gives you the number of successes, you can go straight ahead and input that in your calculator. We are comparing two proportion, therefore that's a two proportion z-test. All right, so let's do that test. Two proportion z-test. Our first x value is 31. Our n1 is 1,000. Our x2 is 22. And our n2 is 1,200. Our alternate hypothesis is the not equal sign. And then we're going to calculate. Over here, our test statistic rounded to 2 decimals is 1.93. So this one's pretty close to 2, so we're going to have to really look at the significance level. So this could be either rejected or not, right? It could be unusual or not. So let's check the p-value, which is 0.0537. And we're going to compare the p-value with our significance level. And this one is greater than 0.05. So we said when the p is low, we're going to reject, but this one is greater, therefore we're going to fail to reject. Okay, so we have a two-tail test over here. What is the area in each tail? Yeah, half of 0.05. And so we're going to have the plus or minus. These are z-scores. What do we use to find these z-scores? Inverse norm. Area to the left, which is 0.025. So second vars, inverse norm, 0.025, area to the left. And our critical values are plus or minus 1.96. So we have the negative one over here, we have the positive one over there. These two are symmetric, so we can, once we find one, we have both of them. Our test statistic is just slightly less than our critical values, so therefore it falls into that middle region, which is the fail to reject zone. Our two tails are our rejection zone. So same conclusion based on the critical values or the p-value method. Okay, our conclusion on the claim. Our claim was in the null. So we're going to look at our wording. Our original claim did include the equality. And then we failed to reject it. So what is our wording? Yes, there's not sufficient evidence to warrant rejection of the claim. And what's the claim? That the two proportions are equal. So there doesn't seem to be a significant difference between the two. Now, on your homework assignment, I said, many times we have to find the corresponding confidence interval. So in a two-tail test, with 5% in the two tails, what would be the corresponding confidence interval? So this time it's already, our test is two-tailed, right? So we don't have to change anything and make it into a two-tailed test. It's already two-tailed. We have a total of 5% in the two tails. What's the area in the middle? Yeah, 0.95, 95%. So we're going to look at the corresponding confidence interval doing that two proportion Z interval over here. All our numbers are still in here, so the only thing we have to adjust is our confidence level. We're going to change that to 0.95. And then go enter. This is -5 times 10 to the -4. Written as a decimal number, that's actually it's negative 0.1234, 3 zeros and then a 5. And then it goes to positive 0.0258. So it starts with a negative number and ends with a positive number. So we already said if 0 is included in our confidence interval, that means these proportions are the same. You can see how this is just really barely negative. So again, we're right on the borderline of saying there is a difference or there's not. Just like our hypothesis test, our test statistic was very close to the critical value. Our p-value was very close to our significance level. So, we're right on the borderline there.